Hi, and welcome to DATQVAULT video lectures. This is lecture 1.1, where we're going to talk about simple nomenclature. So, to start off this lecture, we need to look at the first table presented here, which is formulas for unbranched N-alkanes. Knowing this table is going to be very useful on the DAT and will help you solve the formula of many unbranched and branched linear alkanes quickly and efficiently. This table gives us the prefixes and suffixes of many linear N-alkanes. If we notice here, all linear unbranched and branched alkanes end with the suffix -ane and begin with some sort of suffix that describes the number of carbons in the linear or unbranched N-alkane. Methane meaning 1, ethane 2, propane 3, and so on and so forth. Learning this table will be very valuable on the exam. Here are a few examples of structures of unbranched linear alkanes. This one being propane, this molecule with 6 carbons being hexane, and this molecule with 8 carbons being octane. Alright, so now that we know our linear alkanes, we can move on to naming branched hydrocarbons. The first example we have here is a very simple branched hydrocarbon, and we'll go through some basic ways on how to name this branched hydrocarbon. The first technique that we need to use is to find the longest alkyl chain on the branched hydrocarbon. I'm circling the longest chain right here, which is going to be a linear 4-carbon chain, which we can name butane. The second thing we do when naming simple branched hydrocarbons is to number the chain such that the substituent on the chain has the lowest number. The substituent in this molecule is going to be a methyl substituent. If we start numbering the chain on this carbon, we get the methyl at the 2 position. If we were to start naming from the other side, the methyl would be at the 3 position, which would be a higher number. So we're going to pick naming from the right-hand side, or numbering from the right-hand side, so that this molecule will be named 2-methyl butane. Let's do a little bit more complicated example. So the first thing that we need to do, just like in the previous example, is to find the longest hydrocarbon chain, which I've circled here. Again, if we number this chain, we find that no matter which direction we number the chain starting from, we end up with the substituent on this molecule being at the 4-carbon. So this is a 7-membered chain, so it's going to be a heptane. The substituent here is an ethyl substituent, and it's at the 4 position, so we can call it 4-ethyl heptane. Alright, let's get a little bit more complicated. This hydrocarbon, again, we're going to find the longest alkyl chain. So there are actually 2 options in this molecule. We can start from this carbon and end at this carbon here, and will give us an 8-carbon chain. But we can also start from this carbon and end at the same carbon down here, and we get an 8-membered chain as well. So how do we choose which carbon to start from and end from? The rule here is that we want to have the largest number of substituents on our carbon chain. So if we start from the left-hand carbon over here and end on the right one, we end up with 3 substituents, and starting from the top to the bottom carbon, we only end up with 2 substituents. So I'm going to circle this chain as our longest carbon chain. So if we start numbering the carbon chain from this side, we're going to have the substituents with the lowest numbers on them. If we started from the right-hand side, we would have a much higher number of substituents. So this is an octane chain. These substituents here are methyl substituents. And the substituent right here is a propyl substituent because it has 3 carbons. Alright, so now that we have 2 substituents, we need to put these in alphabetical order, which is our next rule if we have more than 1 substituent on our hydrocarbon. So methyl comes before propyl in the alphabet, So we're going to start with 2,4-dimethyl. We're using the prefix di in this case because there are actually two methyl groups in this compound. And then this is going to be hyphen and then 4-propyl octane. Alright, so this is a simple way to name branched hydrocarbons. So let's move on to the next section, which is cyclic hydrocarbons. Here I have an example of the most simple cyclic hydrocarbon, which is going to be cyclopropane. We name these hydrocarbons very similar to linear hydrocarbons. First we find the number of carbons in the molecule, in this case the cyclic form, and it's called propane because there's 3 carbons in it, and then cyclo means it's in a cyclic form. Alright, let's get a little bit more complicated. Here we have a 6-membered ring, so we're going to call this one a cyclohexane. So we start numbering the cycle as we would just like a linear chain to where the substituents are given the lowest number. If we start numbering from this carbon, we have 2 substituents on the 1 carbon and 1 substituent on the 3 carbon, giving us the lowest overall number. This here is an ethyl substituent because it has 2 carbons. Again, we have 2 methyl substituents on the 1 carbon. Ethyl comes before methyl in the alphabet, so we're going to start with 3-ethyl, 1,1-dimethyl hexane. Alright, let's do one more example, getting again a little bit more complicated. So we notice we also have a ring in this molecule, and this one is going to be a 4-membered ring, so it's going to be cyclobutane. Notice how important knowing that table is for knowing the number of carbons in either the ring or the linear form. Alright, so we could name this giant substituent off of this cyclobutane ring, but that was going to be extremely complicated. So what we're going to do in this instance is actually take the longest chain, which is this chain right here, and have the cyclobutane be the substituent off this longest chain. So this chain is 10 carbons long. So if we number it starting from the left-hand side to the right-hand side, substituents are at the 3 and 6 carbon, giving us the lowest number once again. The substituent up here, if we're using the common naming scheme, would be an isopropyl substituent. But since on the DAT they look for mainly IUPAC names, the substituent is going to be 2 carbons long with a methyl group at the 1 carbon. So this is actually going to be, based on IUPAC naming, 1-methyl ethyl. So to name this overall molecule, C comes before M in the alphabet. So we're going to start with cyclobutane. So this is going to start with 3-cyclobutane. Six, and then if we're using the IUPAC naming, since there's a number in front of this substituent to begin with, we're going to put it in a parentheses, 1-methyl ethyl. And then it's a decane. Alright, so we're going to go on and do a sample question similar to one that you might see on the DAT. So this question asks us, what is the structure of 2-isopropyl 1,4-dimethyl cyclohexane? Similar to the DAT, you're going to be given 5 different choices. So I'll give you a second to answer this question, and then we'll solve it together. Alright, let's solve this question and see if we got the same answer. Since you're actually not going to be able to write on the DAT, you'll be given a blank sheet of paper similar to this. So I'll show you how to solve it on this sheet of paper versus actually writing on the exam. The quickest way to solve this problem would be to actually draw out the structure and see if your structure matches any of the ones over here in the answers. I usually start with the main hydrocarbon chain or cycle. In this case, we're going to have a cyclohexane molecule. So I'm going to draw a cyclohexane, which is a 6-membered ring. Now I'm simply going to number each carbon on this ring and then put substituents onto the numbered carbons. We notice we have a isopropyl group at the 2 position. So if we remember what isopropyl looks like, I said it was the common name for 1-methyl ethyl. So you should probably know the common names of many substituents, such as this one, as they might show up on the DAT. So we're going to put a methyl group at both the 1 and the 4 position of the cyclohexane. So now let's see if this molecule matches any of our answers. And of course it does. Answer C looks to be the same structure as the one we've drawn. So we're going to answer C. Alright, let's go to the last section of the simple nomenclature lecture, which is going to be halogenated hydrocarbons. We name these molecules very similar to just basic linear hydrocarbons, except we need to know how to name halogen groups. Alright, so let's name this molecule here. We follow the same rules as before, and we find the longest alkyl chain. In this case, we're going to have a heptane. We're again going to number the carbons such that the substituents have the lowest number. These are methyl groups. This is a bromine, so we're going to call this a bromo substituent. B comes before M in the alphabet, so we're going to start with 5-bromo, 2,2-dimethyl heptane. Alright, let's get a little bit more complicated. So in this molecule, we have a cyclic 5-membered ring, so it's going to be cyclopentane. So in this particular molecule, we can name it or start numbering the ring one of 2 different directions to give us the lowest number for the substituents. We can start numbering from the methyl group, so this carbon being 1, this carbon being 2, chlorine bearing on the 3rd carbon, and then fluorine on the 4th carbon. We could also start numbering the chlorine as the 1 carbon, fluorine is 2, this hydrogen right here as the 3 carbon, and then the methyl group would be on the 4 carbon. So now we need to know which one has priority to be the number 1 carbon, the carbon bearing the methyl group or the chloro. So know that alkyl groups actually have lower priority over halogens when numbering the carbon chain. So this chlorine is going to be the 1, fluorine 2, 3, and then the methyl group will be on the 4 carbon. So similar to the example before, this one's going to be chloro. This fluorine is going to be called a fluoro substituent. We have a methyl. Following the alphabetical rule, chloro comes first, so it's going to be 1 chloro, 2 fluoro, 4 methyl, cyclopentane. Alright, let's do one more sample question. In this question, they want to know the IUPAC name of the following halogenated compound. So I'm going to start by letting you guys solve this problem without seeing the answers as you normally would on the exam. So go ahead and hit the pause button and try to solve this question without seeing the answers. Alright, let's solve this problem together and see how we did. Just like the DAT, we're given 5 different answers. And now we're going to try to solve this question over here on the blank piece of paper. So to solve this question, I would start by actually drawing the molecule out and then numbering and circling things on the molecule. Alright, so if we find the longest hydrocarbon chain on this molecule, it's going to be this one, this 6-carbon chain. So this is going to be a hexane. Alright, if we start numbering from the left-hand side, we'll get substituents with the lowest numbering pattern. These substituents up here are bromo substituents. And then down here we have 2 methyl substituents. Alright, the bromo substituents are on the number 2 carbon, and there's 2 of them, so we need to have 2, 2. And then don't forget to put the di in front of the bromo since there are 2 of them in this molecule. Same with the methyl, where we have methyl groups on the 3 and the 5 carbon. And we're also going to put di in front of the methyl because there's 2 of them in the molecule. Now, if we follow the alphabetical rule, B comes before M in the alphabet, so 2,2-dibromo, 3,5-dimethyl hexane should be our answer. So let's go see if any of those are in the answers. If we look at A, we notice that it is indeed 2,2-dibromo, 3,5-dimethyl hexane. But now let's eliminate other options just to make sure we didn't make a mistake. So we think the answer is A. Let's look at B and see what's wrong with it. So if we notice, if the molecule bears 2 of the same substituent, we need to number both of those substituents. Here, dibromo is only given 1 number, so we can eliminate that one from our choices. If we look at C, we notice that the longest carbon chain here is a butane chain. We've already figured that the longest carbon chain has 6 carbons, so this one can be X'd out. Answer C, we see that there is a 3,5-dimethyl and a 2,2-dibromo, but of course the alphabetical order rule is not followed, so we can mark this one out as well. In this example, E, we find that they start numbering from the right-hand side of the chain to the left-hand side of the chain. So we can X that one out for sure. So now, eliminating all the other ones and having A match our initial answer, we can for sure call A the correct answer in this sample IUPAC naming question. This concludes lecture 1.1 of Simple Nomenclature, and I look forward to seeing you again for the next lecture.